Hey everybody, so today we're going to just look at a couple more quick proofs. We're going to be on page 47 in your packet, so if you could take that out. We already did the top proof. We're going to look at the proof on the bottom of page 47. I know it looks complicated, but it's really not too bad. And there's one thing I wanted to show you that comes up with this. So first of all, let's see what we got for givens and mark up our picture. F is the midpoint of GH. F is the midpoint of GH. So what does that mean? GF, oops, I don't know if I wrote it correctly. GF is congruent to HF because it's the midpoint. Definition of midpoint. Now the next one talks about midpoint too, so if you want, you can just add this to number 6. E is the midpoint of AD. So DE is the same as AE. And notice I use different markings because it's not the same size as GF. All right, and again, I'm just leaving that on number 6 because they're both definition of midpoint. All right, so now it says FE is the same as ED. Well, if you notice, ED has 2 markings already. So if FC is the same as it, I'm going to put 2 markings here. Same with BF is the same as AE. So again, down here, AE is the same as BF. So I'm going to put 2 markings there as well. So therefore, if you notice, CF and BF both have the 2 markings, so they're both the same. Since they're the same, since they're congruent to 2 things that are congruent, they're also congruent. So that's what's called substitution, right? If these 2 are congruent and DE and CF are also congruent, then CF is also congruent to this. All right, it's substitution. You could also consider it the transitive property, but substitution's easier. So now I'm just going to say, since these are the same as these, and these are equal, we can say CF is the same as BF. CF is congruent to BF by substitution. Okay, so those are both done. It just says that these intersect. That's really nothing other than the fact that if you look, angle 1, which we want to put a little 1 and a 2 in, and angle 2 are congruent because they're vertical. And then we can prove our 2 triangles that it's asking us to prove are congruent by side angle side. So angle 1 is congruent to angle 2 because vertical angles are congruent. Now again, if you don't put the 1 and 2 in, you could say angle GFC, but you'd have to make sure to say angle HFB. It's really important that you get the order down. So I like to just put a 1 and 2 in there and use that, but totally up to you. Again, if you wanted to use that, you could say angle CFG is congruent to angle BFH. But that's just if you don't want to use the numbers. All right, so now what it asks us to prove, triangle GFC is congruent to triangle HFB. And the reason, look at your picture, side angle side is congruent to the other side angle side. All right, the other proof I wanted to look at with you is on page, oh, we did that one already. Oops, backing up. 49 at the bottom. You didn't have to do the top one, but 49 is a little tricky. I'm going to prove this first. We could prove the other part as well, but it gets a little bit messy. So I just wanted to look at that part of it. All right. So we're going to get our statements and reasons set up. If you want to pause the video and do this, you can. At any point, if you need to pause the video, go for it. So if I'm going too fast or whatever, ED is congruent to FD. EB is congruent to FC. And number 3, DA bisects EF. So those are our 3 givens. You could write given 3 times, or you can just write it like that. All right, so let's mark up our picture. That's important. ED is congruent to FD. So ED, that whole side, is congruent to FD, that whole side, which makes it what type of triangle? 2 congruent sides, isosceles. So that's where I'm going to begin. So triangle DEF is isosceles. And we knew that because it has 2 congruent sides. So an isosceles triangle has 2 congruent sides. All right, it's just on its side. That's okay. So these are the same, which means the angles opposite them are the same. So angle E is congruent to angle F. We can start there. And again, you can say definition of isosceles, or you can say base angles are congruent. All right. Now, let's back up a little bit. It wants us to prove AB is congruent to AC. It didn't tell us that. That's what we want to prove. Since those are parts, your very last statement is going to be that by CP, CTC, corresponding or matching parts of congruent triangles are congruent. So we first have to prove that these 2 triangles are congruent, then we can prove that their parts are congruent. All right, let's see what else they gave us. So that all came from just that one statement. 2 sides are congruent, got an isosceles triangle, and base angles. EB is congruent to FC. Oh, we have a side of those. Okay, so we have a side and angle. DA bisects EF. So EF is being cut in half, so that means EA is the same as FA. And that's definition of bisect. And now look at what we have. We have side, angle, side. We have, here's our side, here's our angle, here's our other side. So we can say that those 2 triangles are congruent by side, angle, side. So I'm just going to go in order A, B, E, alphabetical order for my first triangle. And that's congruent to the other triangle. Since we started with A, and then to B, we have to do A, C, F. And again, I typically go alphabetical order. You don't have to, though. All right, that was by side, angle, side. And so since those 2 triangles are congruent, all their parts are congruent, so we can say AB is congruent to AC, what it wanted us to prove. By CPCTC. And again, that stands for corresponding, which means matching, parts of congruent triangles are congruent. Matching parts of 2 triangles that are congruent. So once you say the 2 triangles are congruent, you're good to go. All right, we're going to stop there. Last proof video of the unit, and then we have review in your test coming Monday. Have a great day.